In the previous video, we studied a measure of central tendency, a concept of expected value or mean of random variable. In this video, we are going to develop a similar concept for measure of spread that we applied for sample variance. So variance is a single number that is going to show us the spread of a random variable. Let's take a look at the following two PMFs. Let's say here we have a first random variable, and let me color in blue the PMF of a second random variable. Let's extend this line a bit. Now, let's assume that those two random variables have the same mean, have the same expected value, represented somewhere here, which we are going to represent by mu. Which is an expected value of two random variables, x and y. Now, if we take a closer look at our plot here, we can see that blue random variable, the PMF of blue random variable is more spread than for the red one. Now, we measure variance in a similar fashion that we did for variance over a sample. So if you recall, we were looking at the distances of values of our sampling points from its mean. Now here we will be looking for distance from the value of our random variable to the expected value of that random variable. So let's assume that our experiment has already been conducted and we know the value of random variable. Let's assume that it happened to be to this value over here. Then we are going to measure this distance over here. We know that if we sum all of these distances here, in the case when we're working with sample variance, we know that they are going to cancel, the positive ones are going to cancel out the negative ones. And we had to move on to the absolute value, either absolute value of that difference here, or we squared those distances for the mass to work better. In that case, we will also be working with squared distances of values of random variable from its mean. So rather than looking at expected value of difference of the value of random variable from its mean, which is going to be equal to 0, we are going to look at expected value at those squared distances. Now, this value over here is known as the variance of random variable x, which is equal to the following sum over all values of x minus mu squared multiplied by PMF of x. By the definition of random variable, by the definition of expected value of random variable function. Now, if we apply further derivation, we are going to get the following short form: the sum over all values of x squared, multiplied by PMF of x minus mu squared. Now, this mu squared is outside of the brackets here, and mu corresponds to expected value of random variable x. So here we have a definition for variance of x, variance of a random variable. Now, it is also denoted as sigma squared. So this is denoted as sigma squared.